Dear students, the previous session discussed about division of objects into groups. Now we are going to see one example illustrating that concept. In how many ways can a pack of 52 cards be distributed equally among 4 players on order. Divided into 4 groups of 13 cards each. Divided into 4 sets three of them having 17 cards each, and fourth just 1 card. Totally here we have 52 cards. So number of total we have 52 cards. Thirteen cards each. So 4 equal groups, among 4 players only. number of ways equal to total we have 52, that is 52 factorial by 4 players 1 2 3 4, that is 4 factorial. Each player will have 13 cards, that is 13 factorial power 4 into 4%, that is 4 factorial. So this will be cancelled. 52 factorial by 4, that is mn factorial by n factorial whole power m into m factorial into m factorial formula can be applied. The next concept, the same question, 7 parts. Only 4 groups only, not 4 persons, 4 groups. That means number of ways 52 factorial by 4 factorial into 13 factorial power 4. That is mn factorial by m factorial into n factorial into m factorial power n. So 1 by m factorial n factorial power m. M groups, that is 4 groups. Next, third subdivision, 4 groups, 3 of them having 17 cards and 4th just 1 card. So 17, 1 card. Here we divide 52 cards into 2 sets which contain 1 and 41 cards respectively. So in this case, the number of ways (52 factorial by 1 factorial into 51 factorial). (51 cards are can be divided into 3 sets each contain 17 cards. Number of is 51 factorial divided by 3 groups 17 cards each whole power 3. Therefore, the required number of is 52 factorial by 15 factorial into 51 factorial by 3 factorial into 17 factorial whole power 3. That is 52 factorial into 3 factorial 17 factorial whole cube. In how many ways can sixteen different books be distributed among 3 students A, B, C, so that B gets 1, one more than A, and C gets 2 more than B. Solution. Let's A gets n books, then B gets n plus books and C gets n plus 1 plus 2, that is n plus 3 books. Total number of books n plus n plus 1 plus n plus 3 equal to 16, which means 3n equal to 12, n equal to 4. So A gets 4 books, B gets 5 books, and C gets 7 books. Total is 16. One group 4, another person 5, then 7. The total number of ways for the required distribution. We have 16 factorial by 4 factorial into 5 factorial into 17 factorial. In how many ways can 9 different books be distributed among 3 students and if each receives at least two books. So totally 9 books are there. We have to distribute to 3 students. Each one have at least 2 books. Nine, 2, 2, 5. Another possibility 2, 3, 4. Another possibility 3, 3, 3. So total number of ways distribution of books. Among 3 students is equal to, here numerator 9 factorial, here 2 equal groups. So 2 factorial whole squared. Separately we have 5 factorial. Since we have 2 equal groups, you should apply 1 by 2 factorial plus here 9 factorial by 2 factorial, 3 factorial, for there is no equal groups, no problem, plus here 9 factorial 3 fact whole cube into 3 factorial. Since there are 3 persons, we have to multiply by 3 factorial. Nine into 8 into 7 into 6 into 5 factorial divided by 2 factorial means 2 squared 4 into 5 factorial into 1 by 2 plus 9 into 8 into 7 into 5 into 4 factorial divided by 2 into 6 into 4 factorial plus 9 factorial by 3 factorial 6 into 6 cube into 3 factorial, that is 6 into 3 factorial 6. This will be cancelled. This will be cancelled. 6 will be cancelled. And 63, 4 into 5, 20. Plus 9 into 8 into 7 into 6 into 5 into, okay, have 3 factorial, 4 into 3 factorial divided by 6 into 6 into 6 into 3 factorial. This will be cancelled. This will be cancelled. 3 times 9, 2 times 6. 2 times 2 into 4, 4 will be cancelled. $378. Here 8 into 7, 56 into 5 plus 280 into 6. So 11,508. Next concept, arrangement in groups. The number of ways in which n different things can be arranged into or different groups is r into r plus 1 into r plus 2 etc. r plus n minus 1 or n minus 1 n factorial into n minus 1 c r minus 1. According as blank groups or if blank groups are not admissible, you can apply this. Blank groups are admissible, you can apply this result. Example. In how many ways five different balls can be arranged into three different boxes so that no box remains empty. In how many ways five different balls can be arranged in three different boxes so that no box remains empty. The required number of ways n factorial into n minus 1 c r minus 1. Five different balls are there. Therefore, n takes value 5 factorial into n minus 1, that is 5 minus 1 c. Three different boxes, that is r equal to 3 minus 1. We apply this formula because no box remains empty. For this is the formula. So 5 factorial means 120 into 4c 2. 120 into 4 into 3 by 1 into 2. 2 times 120 into 6. That is 720. Second results. The number of ways in which n different things can be distributed into all different groups is r power n minus rc1 into r minus 1 whole power n plus rc2 into r minus 2 whole power n. So minus 1 whole power r minus 1 into into RC R minus 1 or sum of P equal 0 to R minus whole power P RCP into R minus P whole power N. Or coefficient of x power n in n factorial into e power x minus 1 whole power r. In this case, blank groups are not allowed. In how many ways? Five different balls can be distributed into three boxes so that no box remains empty. So r power n minus rc1 r minus 1 whole power n plus rc2 r minus whole power n minus rc3 r minus 3 whole power n. In this case, r means 3, n means 5, 3 power 5 minus 3c1 3 into 2 power 5 plus 3c2 r minus 2 1 power 5 minus rc3 3c3 r 5. So 3 per 5, that is 243. 3 into 2 per 5 32. 3C2 means 3C1 equal to 3. This same equal to 0. So 243 minus 96 plus 3. 246 minus 96. That is 150. If n of a equal to 5, n of b equal to 3, find number of onto mappings from A to B. Onto mappings, there will not be blank. Blank is not allowed. This is equivalent to number of ways in which five different balls can be distributed in three different boxes, that is images. If no box remains empty, so the total number of onto mappings from A to B is R power n RC1 R minus whole power n plus RC2 r minus whole power n minus etc. So 3 power 5 minus 3c1 3 minus 1 whole power 5 plus 3c2 3 minus whole squared minus 3c3 3 minus whole cube. That is 243 minus 3 into 2 power 5 3. 243 into 32 plus 3. 246 minus 96, that is 150. Result 3. The number of ways in which n identity things can be distributed into R or different groups is n plus r minus 1 c r minus 1 or n minus 1 c r minus 1. According as blank groups are not admissible. If blank groups are admissible, you can apply this formula. Otherwise, you have to apply this formula. In how many ways five identical balls can be distributed in three different boxes so that no box remains empty. The required number of ways. The required number of ways. Empty is not allowed. So n minus 1 C r minus 1. So 5 minus 1 C 3 minus 1, that is 4 C2. 4 into 3 by 1 and 2, that is 6. Four boys picked up 30 mangoes. In how many ways? Can they divide them? If all mangoes be identical, thirty mangoes can be distributed among four boys such that each boy can receive any number of mangoes. So total number of n plus r minus 1 C r minus 1. $30 plus 4 minus 1 C 4 minus 1. Any can receive any number of mangoes. That means even blank is applicable. Suppose one person may not have any mango. That means 0 mango, one person can get it. So 33 C3. 33 into 32 into 31 by 3 into 2 into 1. It's 11 times. Here 12 times. So 31 into 12 into 11. $33, okay, sorry, here 16. $16 times 32. So 5, 4, 5, 6. So there is a possibility of applying admitting blanks group. Therefore, you have to apply the formula n plus r minus 1 c r minus 1. Apply and simplify. You will get the answer. Using this concept, we will discuss different types of sums in the next session. Thank you.